Hey, good morning, guys. So, from today onward, we are going to explore the world of physics. Uh, I have divided each of the chapter into two parts. First one is theory, and second is exercise questions. Okay. So, there are multiple videos for each of the chapter. So, I would suggest you to go through theoretical videos first, followed by solving exercise questions. I have I have taught the concepts in a way that they become crystal clear in your mind. So when things are so clear, speed will automatically come. Okay, and I'm sure exercise questions will be just a cakewalk for you. Take my word, it will be a cakewalk for you. So let's start. Good luck.
Yeah, guys, the first topic which we are going to talk about is what we mean by motion of an object, or when can we say an object is moving. So let us take an example. Okay, suppose you are standing in a sorry, you are standing in a cricket ground. Okay, and staring on a ball. You are stationary. Yeah. And staring at a ball. You are staring at a ball. The position of the ball is this. Let us say at time t equal to t1. After some time, let us say at time equal to t2, you notice that the ball is here. So what you see, we clearly see that with the passage of time, the position of the ball is changing. Earlier it was here and now it is here. So what can we say about this? We can clearly say that the ball is moving towards us. Agree? So this is motion of an object in a very simple term. Let us take another example. You are traveling in a bus. Okay, this is you. Okay, you are standing bus, and there is another bus which is moving in parallel to this bus. The buses are very close to each other. Okay, and the bus is moving in the same direction with the same speed. let us take let us say the speed of the bus is v, for example. Again I repeat, the bus is traveling in the same direction with the same speed. Okay, this is you and this is your friend. So if you continuously stare at your friend, what you will notice? You will notice that you are at rest or your friend is at rest with respect to you. Okay, you just continuously stare at each other. Both of you will find that you are at rest. This is the case, but in reality the bus is moving. Do you see the difference? Now let us say there is another person who is waiting for the bus at the bus stop, right? Obviously this person is at rest. So let us choose a reference point for this person. For example, let us say this is the reference point for this person who is waiting. With the passage of time, this person notices that the position of you or your friend is continuously changing. So what we mean by this? That means you are moving with respect to this person, but both of you are at rest with respect to each other. So what can we say about the motion? So motion of a particle or an object is relative in nature. Okay, so I have written down something for you, so you can write this as a definition of motion of an object. What we mean by motion of an object. So an object can be said to be in motion when its position changes with respect to a reference point. See, I have taken this particular point as a reference point. Motion of an object is always relative in nature. Okay, so this is the definition which you can write in your exam, and you can suffice this particular example. Now suppose again you are standing in a field, okay, and you are observing that some sand particles are entering into your eyes, okay, and leaves of plants are continuously moving, or trees are dancing. So what can you infer from this? I think you can clearly say wind is blowing. Yes, you're right. So movement of wind is something which we cannot perceive directly. Why? Simply because it is invisible to us. Wind is invisible to our eyes. So if I ask you, in how many ways we can perceive motion of an object? See, in how many ways we can perceive motion of an object? So there are two ways, direct and indirect. So direct is something we are seeing the ball, we are seeing the bus, okay, and but wind is something which we cannot see directly. So motion of wind, okay, we can perceive indirectly. The next topic is types of physical quantities. So under types of physical quantities, we can say there are two types of physical quantities. One is simple scalar, we call it scalar, and another one is called vector. Okay, so scalar is a physical quantity which has magnitude only. Guys, pay attention please. Magnitude only. It has magnitude only. Okay, and vector is magnitude, okay, plus direction. So let us take an example of scalar. So very simple example which you can quote is distance. And an example for vector can be displacement. Okay, so these two are the simplest physical quantities. So let us try to understand these two physical quantities first, and then we will revisit the concept of scalar and vector. So what is distance? Suppose you are going to a park for jogging, and park is circular. You started from here and you are taking anti-clockwise run. Okay, you ran for say 3.5 rounds. Okay, first round you completed, you reached here. Second round, third round, at the end of the three and a half round, okay, your position will be here. Okay, the reference point which I am taking is, it is very important for us to take reference point. Okay, the reference point which I have taken is this particular point, the point from where the person started running. Okay, so if you see, after completing 3.5 rounds, what is the position of the person? It is just the, it is nothing, it is the diameter. Okay, how far it is from the reference point? Let us denote initial position as I and final position as f. So what is the distance between final position and initial position? I mean, when I say distance, that is the shortest distance basically I am looking for. So it will be diameter. Okay, and what is distance? What is the real distance you cover while making 3.5 rounds? It will be 3.5 into periphery of a circle, 2 pi r. So are you seeing the difference? That the actual displacement which happened is just the diameter of the circle, but the distance which you cover is this much. There is huge difference between these two. So what is displacement? Displacement is the shortest distance between final and initial position. Okay, it is the shortest distance, please pay attention. And distance is nothing, distance is the length of the route. See, First round, how much is the length which we have covered? 2 pi r. Second round, 2 times of 2 pi r. Similarly, 3.5 times of 2 pi r. So that is what I'm saying. Now let us come back to the definition of scalar and vector and see. See, this is type of physical quantity is scalar, magnitude only, vector, magnitude and direction. The examples of 1a, that is scalars, are distance, mass, time, speed. Okay, and examples of vector are displacement, velocity, acceleration, momentum, force. So some of the physical quantities you might not be aware of, so don't worry about that, we will take care of it. Okay, so till now we know about distance and displacement. Okay, and see, this is the definition of distance which I have written for you. So distance is what is distance? Distance is length of the path traveled by an object. Okay, it has magnitude only. See, it is the length of the path. Okay, see this is distance. We denote distance by letter S usually. And what is displacement? It is the shortest distance between the initial and the final position when an object moves. It has magnitude along with direction. So till now we know that the displacement, the shortest distance is diameter. Okay, in which direction, if I ask you, in which direction the displacement took place? So let us adopt a sign convention. Say right side of x-axis is positive and left side of x-axis is negative. We are adopting this sign convention. So as per this sign convention, the displacement will be, that is displacement is shortest distance between final and initial uh, position. Okay, so it will be diameter. In which direction the displacement has taken place? Negative direction. So this is the value of displacement. Okay guys, now let us analyze motion of an object along a straight line. Okay, suppose the object is here. Okay, and let us take this as the reference point. This is the reference point also. Okay guys, so a point. The object traveled from A to B this much, and the distance between A and B is 40 meter. Okay, if I ask you what is the distance which is traveled by the object, S, we denote distance by letter S. Okay, from A to B, it will come out to be 40 meter. Fine, fantastic. What is the displacement covered? Displacement of the object, displacement of the object from A to B, it will be plus 40 meter. I am referring to the same sign convention which we discussed just a minute before. Okay, it is moving in the positive direction. Yeah, now suppose after reaching point B, object started moving in the reverse direction. Suppose it moved till point C. Say the distance between point B and C is, say anything, 12 meter. Okay, now if I ask you what is the distance covered by the object from A to B to C, what will be your answer? It will be 40 meter plus 12 meter. Fine, so it will come out to be 52 meter. And the displacement will be A to B to C. The displacement will be how much? What is the initial position of the object? This. What is the final position of the object? Is this. What is the shortest distance between A and C? That is 40 minus 12. 40 minus 12, so it will come out to be 38 meter. So do you see the difference between distance traveled and displacement? Distance is coming to be 52 and distance is 38. Now suppose object moved from C to C and it reached to A, to its original position. Now let us try to know the difference. A to B to A. The distance traveled from A to B to A is 2 times of 40 meter, so it will come out to be 80 meter, right? And what is the displacement from A to B to A? Since the final and the initial position of the object is same, so as per the concept there is no displacement. See the difference. There is distance traveled by the object is 80 meter, but displacement is 0, no displacement, right? Suppose after reaching A, object moved further in the leftward direction. Say it reached here D, and the distance is say 15 meter. What will the distance traveled by the object A to B and then to D? It will be 80 plus 15 meter, 95 meter, fine. And how much is the displacement, sorry, displacement A to B to D? Final position of the object is D, initial position is A. Object has moved in the negative direction, so it will come out to be minus 15 meter. So again you should be able to see the difference, big difference. Distance traveled is 95 meter, displacement is minus 15 meter. Okay, so distance is a scalar quantity and displacement is a vector quantity. So the next concept which I am going to talk about is speed and velocity. See, here it is written the next speed and velocity. Speed is scalar quantity and velocity is a vector quantity. I will try to explain it to you. Okay, suppose you have covered 40 meter. So is it possible for you to cover this 40 meter distance in 0 time or in no time? Of course not. It is a strict violation of everything in the world, in the universe. Okay? So you must buy some time to cover a certain distance, right? So while saying this, something comes in my mind that there is a factor. Okay, there is a factor. Factor, when I say this is a mathematical factor I am talking about, there is a mathematical factor which we maintain. Okay, which we maintain while covering a distance. Okay, for example, I may have covered this 40 meter distance in a duration of say 9 seconds, or maybe 8 seconds, or maybe 10 seconds. I must have bought some time duration in order to cover this 40 meter, right? So that means there is a factor, there should be a factor, right, which can tell us like how much distance we cover per unit time. So this per unit time I am taking second for now, okay, for this example. So I can say I have covered 5 meter per second. I can denote it by this particular symbol, 5 m by s, 5 meter per second. So that means I have covered 5 meter in 1 second, right? In the next second also I covered 5 meter. In third second also I covered 5 meter, right? In fourth second also I covered 5 meter. So there is a factor with which we travel a distance, and that particular factor which we are talking about is nothing but speed. So speed is a mathematical factor actually. If you see, It is distance traveled per unit time. So I have written down something for you. You can see what is the speed. Speed is distance traveled per unit time. Okay, it has magnitude only, you know, because it's a scalar quantity, and the SI unit is meter per second. See, this is a very important example. Speed given is 5 meter per second. There is an object which is moving with a speed of 5 meter per second. So by knowing this, can you, if I ask you in which direction the object is moving, can you tell me? You can't tell me, because speed simply denotes the magnitude. Okay, it doesn't talk about direction of movement. Yeah, so this is what I have written. By knowing speed only, we can't say in which direction an object is moving. Okay, so speed is just a magnitude, just keep in mind. So other units of speed can be kilometer per hour. You must have come across this term while watching cricket matches or driving. You must be knowing this: kilometer per hour, mile per hour, centimeter per second. So while solving a numerical question, so it would be good if you start taking the values of the physical quantities in terms of their SI unit. Suppose the speed is written as 5 kilometer per hour. Okay, and if you want to convert it into meter per second, then will you be able to? I think you should be. So let us try to do it. In 1 kilometer there used to be 1000 meter. Okay, and in 1 hour there used to be 3600 second. Fine. So if you divide, you will get a factor of 5 by 18. Okay, and if you just, so that means what I'm saying is 5 into 5 by 18, some value will come out. You can calculate. Okay, so that will give you the speed in terms of meter per second. So just keep in mind this 5 by 18 factor. Okay, using this factor you can convert speed from kilometer per hour into meter per second. This will be useful while solving numerical questions. So now coming back to the same example, which is, so with the speed we don't know the direction of motion, right? So is there a physical quantity which tells us speed along with direction? Yes, and that is called velocity. So velocity is nothing, it's see, just again I'm coming back to speed. Okay, what is speed? Speed is denoted by v. Okay, speed is s by t, that is total distance traveled by time spent. And what is velocity? It is a vector quantity. It is displacement by time, how much a particle has displaced per unit time. Okay, this is displacement, this is velocity. Since displacement is a velocity, so uh, displacement is a vector quantity, so velocity is a vector quantity. So this is what I have written for you. So velocity is speed in a definite direction. Okay guys, in a definite direction. Yeah, this is the key word here. It tells us how much a particle is displaced per unit time. So mathematically what can you say? It is displacement per unit time. So now if I say this, if time is given and velocity is given, and if I ask you to calculate displacement, will you be able to calculate? You should be, right? Very simple calculation. So now the same thing which is given here, the we are referring to the same sign convention, right side plus and left side minus. Now the velocity has given minus 5 meter per second. So what can you say about the direction of movement? The particle is moving in the left, in the negative direction. Particle is moving leftward with a speed of 5 meter per second, right? So now I'm going to ask a question to you. So what all factors can affect the velocity of an object? Can you tell me? See, velocity velocity is a vector quantity, right guys? So we know that a vector quantity has magnitude and direction. So now what do you think? If I change, if I bring a change in the magnitude, it will bring a change in the vector. It is as simple as that. So similarly, if I bring a change in direction, delta denotes a change here. Just keep in mind, delta means change. If I bring a change in direction, so that means I am changing uh, velocity. And thirdly, if I bring a change in both magnitude and direction, right? So that means I am changing velocity. So there are three ways by which we can change the velocity. So this is what I have written: three factors which can affect the velocity of an object, which can affect the velocity of an object. So bring a change in magnitude, change in direction, or change in both.